Hello everyone, myself Gayatri Bajpayee. This video is the second part of binomial theorem and the expansions. The first part is given in the previous video. In this video we will learn if the form like x plus y to the power of n, if n is a negative integer, negative integral exponent, then how could solve that. In the previous video I have explained that x plus y to the power of n, if you are having this type of the form, so how can we make a generalized formula that is called binomial formula for binomial expansion. In this video we will study if x plus y to the power of n and n is having the negative integer, then how can we solve that. If n equals to only -1, n equals to -1, then how can we solve it, and also how can make it generalized formula. So that will be studied through this video. Okay, let's start to learn. So binomial series for negative integral exponent. Okay, negative integral exponent. Previously we have seen x plus y to the power of n, but if we are writing like that, x plus y to the power of -n, so how can we expand that? One more thing I want to tell you what is called binomial series and binomial expansion. If I am telling if I am giving you one series like 1 plus x square plus x cube plus like that, if I am giving up to infinitive, then it is called series. Okay, but if I am taking only some terms like x to power of n or some term x to power of k like that, so these are called the partial sum of n terms. Okay, this is not called series. Okay, and similarly if you are taking only k terms, so this is called the partial sum of k terms. Okay, so previously we have seen the expansion x plus y to the power of n, for which we found one generalized formula where summation of k start from 0 to n, and here we written n k, and it was the x to power of n minus k and y to power of k. So it can be written suppose like that, 1 plus x, suppose this is okay, 1 plus y, suppose x equals to 1. Okay, so 1 plus y square plus up to y to the power of n. So this is not a series, this is the partial sum of n terms. Okay, partial sum of n term. But here if it is going to the infinitive, then it is called a series. And here when you are having the negative integral exponent, at that time it will make a series only, the terms will goes up to the infinite only. Okay, so why, that will understand. Okay, so now I will tell you geometric partial sum. Okay, so that was showing as Sn, which is 1 plus x plus, suppose this is type of parts, this type of the terms are there. Okay, up to x n minus 1. If your summation of n terms, so first term is having n the power of 0, so this was nth term where you are having x the power of n minus 1. Okay, so if you don't remember this geometric partial sum, so I will show you this. It was looking like that when we were studying ar plus ar square plus ar cube, like that it was looking. Means whatever the ratio of this term, that will be always same to ar n minus 1. So the ar divided by 1 should be equals to the ar square by ar, should be equals to the ar cube by ar square, which will be r only. Okay, so ratio of these two terms will always be equal. That is the property of geometric partial sums. Okay, So that is meaning of geometric. Okay. Now how can we find the formula for partial sum? Because this is up, there are n terms. So this is difficult to solve. So some formula will be there. So what that? X, if I am multiplying with this equation with the x value. So x, and that will be x plus x square plus x cube plus x to power of 4 plus up to x to n, and here it will be x and minus 1. Okay, one previous term is there. This is plus. Now we are subtracting these two. Okay, if we are subtracting, so what is happening? It can be written Sn minus x Sn equals to, this will cut, this will cut, this will cut, like that all terms will cut. Only left 1 minus x to the power of n. If I will take x Sn as a common, so 1 minus x equals to 1 minus x to the power of n. So Sn equals to 1 minus x to the power of n upon 1 minus x. We all know this type of formula. We already proven that. So okay, so this is for n terms. When n terms are given, so this is the geometric partial sum of n term. But if n is goes to infinity, at that time what happen? If this term will goes to 0. Okay, so as for infinity terms, it will looks like 1 minus x. Okay, so here if you are taking x equals to plus 2 or minus 2, and n you are taking at this condition 1 or 2, like that, it is giving the summation of these n terms. Whatever n terms, if only one term is there, if two terms are there, then you can take x equals to more than x equals to plus 2 or minus 2, it doesn't matter. But now if this type of this is the equation, this is the summation if your n goes to infinity, that is called the geometric summation of geometric series. Okay, sum of geometric series, geometric series. Okay, so here it's this time the terms is goes to infinity. So the how the terms looks like, so it will be 1 minus x to the power of minus 1. We can write it in this way. Okay, so how the terms will looks like in this situation. Okay, now we have find as infinity. When infinitive terms are there, then the summation of this infinite term will be 1 minus x. We can write in the form of 1 minus x to the power of minus 1. So what was the series for that? Series was 1 plus x square plus x cube. Same series. Whatever I was writing for s n, now I will write for s infinity. The same series will be, but it goes now up to infinity. Now terms will be infinity. That's why it's called series. That is called geometric series. Okay, geometric series. So it is the expansion of this value. So how can we write these things? Okay, this is for when x 1 minus x to the power of minus 1 only. Okay, now if you are taking x equals to suppose, and in this equation it is told that mod of x should be less than 1. So if you are taking mod of x less than 1, then how it will looks? As infinity. So as infinity, it means infinity terms are there. So how can we put this series? So it will, if I am taking suppose x equals to 0.5, okay, less than 1, it is less than 1. So it will be 1 plus 0.5 plus 0.5 whole square, like that, and then up to infinity if I am going. So what does it mean? This is less than this. This is now 0.5 of cube. So this is less than this. So it is converging. The series is converging. If it is converging like this, if you are going, this series is like that, this is type you are converging up to 0, whatever value. So in some point you will get the answer. But if your series is diverging like this, in upside, like this, if it is going, then never you will get the answer. It is diverged. So if you are taking x equals to more than 1, suppose 2, greater than 1 is 2. So at that time the equation s infinity will become as 1 plus 2 square plus 2 cube. Now this time this series is going up to infinity. So this result will never will give you this series any result. This will complete diverge. It's coming upside. Answer is always infinity. So it will not give you any results. So this is diverging type of form. And if you are not finding any result, then there is a no mean of that series. Okay. So for that, because if one x value will less than 1, then only the series will converge. And convergence means what? We will get some result. We will close to the some result. Okay. Converge. Okay. If it is greater than, then series will diverge and we will not get the result. Series will diverge. So that's why we are taking this mod of x is less than 1. And why infinity? Because when Sn was 1 minus x to the power of n upon 1 minus x, when we put this n equals to infinity, so it will be looks like 1 minus x only. So that time it will become like 1 minus x to the power of minus 1. What we have seen the form in the minus integer. So for that it is required it should be infinitive terms, then only it will be made in the form of minus 1. Okay, and this is all. And why this x should be less than 1? Because if x is greater than 1, then series will diverge and we will not get any result. So that's why x should be less than 1. Okay, now we will make this formula. This I have solved for s infinitive is solved for 1 minus x to the power of minus 1. So this type of the term should require. If you are having like a general form x plus y the power of something minus 1. This time I have solved for minus 1 only. So it should be in the form of this form. It should be looks like in this form. So if you are taking x common, so it will be 1 plus y by x to the power of minus 1. And that time you have to write like this way, x 1 minus of y by x to the power of minus 1. So this time your x value will be whatever this value, this x value will be minus of y by x. Okay, so like that you have to make any generalized form to make in this type of the form to solve it. I will take one example, then it will be more clear to you. So if you are taking x, for example, if you are taking x equals to 0.5, which is less than 1. So what was the series? Series is 1 minus x to the power of minus 1 equals to 1 plus x square plus x cube plus up to infinity. It is series. So now I am putting this x value left hand side and also in right hand side. So it will be like this. And here 1 plus 0.5 plus 0.5 whole square plus 0.5 whole cube, like that it will goes. So up to infinity level. So what is the answer of this? 1 upon 0.5. So this will be 5 into 2. So answer is 2. And here just you see, so 1 plus 0.5 plus 0.25 plus 0.125 plus up to is showing if it is going very less, it's keep on decreasing, so it's going up to 0 value. This value, this at the end it will show something like 0.0000, like that it will go. So if I'm adding these 3 terms, these 4 terms, starting 4 terms, so it will be 1 plus this is what, this is 5 plus 7 plus 5 plus 2 plus 7 plus 8. So it is 0.875 means 0.8 it will be 1.875. It is goes to up to 2, whatever result is there, 2. So it will go if I will add some more terms of this addition. So it is goes to whatever our result. It is converging means it is going close to our whatever results is coming. It's coming to some value, and it is not diverging with that. So okay, so these are converging. Now if I will take one example, if x is greater than 1, then what will happen? Okay, so if I am taking one example, x is equals to, okay, if I will take one example, when x is greater than 1, then what is happening? So this is series that we know. Okay, x square, x cube, it is going up to infinity. Okay, so here if x equals to, if I am taking 2, so what is happening? 1 minus 2 to the power of minus 1. So 1 minus of 1 minus 1, so minus 1. It should be close to minus 1. This is our result. Suppose some result should come. It not should be coming some infinity value should come. It should be converged to some value. So here if I am putting 1 plus 2 square plus 2 cube. Okay, so it's a keep on increasing. It's not going value going to the 0. It's a keep on increasing. So it will be 1 plus 2 plus 4 plus 8 plus 16, like that. It's a very huge value will come. It will never close to this result. So if you are watching some graph, through the graph, so this is x and this is y. When your x equals to 0.5, so the answer was what? Answer was 2. So it is getting some results through this series. But when your x equals to 2, then answer is showing some results is showing somewhat it should come minus 1. But what is happening is going on some in other way, and it's completely diverging. It's not closing to this result. So it's completely diverging. It will not give you any results. So for that, it's showing the x should be less than 1. So then only this type of the series is expanded. So okay, now we will see what will be the series when x to the power of 1 minus x to the power of minus n. Then what type of the series will come, that we will learn.